Hey there, so as we continue our journey through algebra basics, we come to solving. We just spent 4 days factoring and now we're going to solve. And there's a reason for that because often when we solve, we want our equation to be on one side in factored form. Not always for sure, but factoring is definitely an extremely helpful skill as far as solving goes. But let's start with some bell work. You should be comfortable with this by now. 8x to the third minus 27. Please factor. We're going to do two factoring problems for bell work, and then we'll start in on solving. Okay, so this is a difference of cubes. You're supposed to recognize it's a difference of cubes. If you don't recognize it's a difference of cubes, you're not retaining the knowledge. Maybe you're not watching the videos. Maybe you're not taking notes. Maybe you are watching the videos and not taking the notes, but not doing the homework. Maybe you're doing all three of those things and still not getting it. Well, here's the thing. You need to get it, which means you need to review a lot more than you are. Okay? So, 2x minus 3, keep this one squared, change this times this, and then the last one is plus this one squared. All right, there's the first one. How about this second one? This might take a little longer for you, but no rational exponents, so no fear. Okay, please factor that polynomial. Might want to pause the video on this one. Okay, welcome back. I see one term, two terms. They both have an x plus 1. One is to the first power, one is squared. We always take out the lowest power, so I'm taking out x plus 1 to the first. Then I see an x minus 3 squared and an x minus 3 to the first. Again, we take out the smaller power, which is x minus 3 to the first. So what's left over? Well, we took out that, and we took out one of these. So we still have this 2, and we still have one of these. 2 and an x minus 3. Then we come to our minus, and what do we have left over here? We have the 3 left over. We took out the x minus 3. We took out one of the x plus 1, so we still have one of those. Okay, well, we need to tidy up what's inside parentheses. We're going to have 2x minus 6 minus 3x minus 3. Many people forget to distribute there. Watch out for that. So we're going to have negative x minus 6 minus 3 is negative 9 times x plus 1 times x minus 3. Now, if this bothers you, you could take the negative out of each of them. Either way is fine with me. Okie doke. Factoring. Can't forget factoring because we need it in solving. So let's take a look at solving. I want to take a look at three main different types of solving today. First, the most basic solving, the solving that you did in Algebra 1 and what that looks like now by the time we get to pre-calc. 2x plus 5 minus 7 equals 3x minus 2. So when you were in Algebra 1, this was a tough Algebra 1 problem. Remember what you did to solve it? Try and think about that now. Remember, we're trying to get x by itself. So I think the first thing I need to do is a bunch of distributing. 2x plus 10 minus 7 equals 3x minus 6. Yup, I like that idea of combining like terms. Good thought. Now what? Well, now we have to get the x's on one side of the equation and the not x stuff to the other side of the equation because this is a linear equation. Well, I don't want to have negative x's, so I'm going to move the x's over here. And then when I add 6, I get x equals 9. Now, this is an ought check. I ought to check this. Uh, the way I check it is to take this 9 and plug it in for these x's. 9 plus 5 is 14 times 2 is 28. 28 minus 7 is 21. And then 9 minus 2 is 7. 7 times 3 is 21. Because we get the same number on each side, I know my answer is correct. But again, this is only an ought check. You know, I might not do it with homework, but I probably ought to do it on a test. Not every equation is an ought check. We're going to come across some in the next couple of videos that are must checks. Okay, why don't you try this one? X minus 3 to x plus 3 equals 8 minus 5x. Okay, now here's the thing. I see a lot of students do some interesting stuff with this. And here's what I see them doing. I see them putting this in parentheses. And so what they do next is they FOIL. And they end up with 2x squared minus 6x plus 3x minus 9. But that's not correct. See, this isn't in parentheses. You know, look at it this way. It's negative 3 times these things. So I've got x. Negative 3 times 2x is minus 6x. Negative 3 times positive 3 is negative 9. And notice there's some like terms I can combine over here. If I add 5x to both sides, I end up with negative 9 equals 8. Is that true? No. So what does that mean? It means there's no solution. What it means is this line and this line never intersect. See, one of the reasons we talked about graphing first was to think about what these algebra equations mean graphically. So if I go over to y1, and I type in x minus 3 parentheses 2x plus 3 in y1 and 8 minus 5x in y2, and then take a look on a standard dealing window, what do you notice about the lines? They're parallel to each other. They both have a slope of negative 5, and so there's no point in intersection between these two lines. If the lines had different slopes, those lines would intersect each other, and that's what a solution to an equation is. Its point of intersection on the graph. Sometimes this function and this function never touch each other, never have a point of intersection, and as a result, there's no solution. Other times, this one sits exactly on top of this one, and so we get an infinite number of solutions. And still other times, I could have a bunch of points of intersection, so more than one solution. Okay, so this one we just did had no solution. Now, I'd like to bridge over to the stuff we were just doing in Bell work regarding factoring, and how I told you in the last videos that this is something that calculus students are going to have to do. Okay, so here's what I say. You can FOIL this out, and you can FOIL this out, and you can distribute and then combine like terms and like terms. But I kind of wonder, is it possible for us to get this to a place where we could factor? Huh. You know, I thought I was going to be able to take something out of each of these, but there's nothing on this side, and there's nothing I can factor out on this side because there's only one term. Well, I guess I do have to FOIL. Come on, not x squared plus 1. Stop it. Please learn from these mistakes. So I've got x squared plus 2x plus 1 when I FOIL, plus 2x minus 4 equals x squared minus x minus 2. Combine like terms. If I subtract x squared from each side, that goes away. I'm going to add x to each side. So I get 5x minus 3 equals negative 2. And then I'm going to add 3, which will give me 5x equals 1, or x equals 1/5. Oh, no factoring there. Oh well, it was worth doing anyway. All right, I'll get you some of those factoring ones, don't worry. It may not be today. So those are sort of the basics. Now I want to come to fractions, solving with fractions. So, for example, x over 5 minus x over 2 equals 3 plus 3x over 10. So here, notice how I have all these fractions? Did you feel your muscles getting tight and your breathing starting to stop? Well, let's get rid of all the fractions. And what we do is to get rid of fractions, we multiply everywhere, not just some places, but everywhere by the LCD, the least common denominator. The least common denominator is not 5 times 2 times 10. The least common denominator is 10. And if you wrote 10 as 5 times 2, you could say, okay, one of what they have in common, so I need a 5 and a 2, and everything they don't have in common. Well, that's just a 5 and a 2. So in our problem, I need to multiply it everywhere by 10, even here and here. So what's going to happen when I multiply everywhere by 10? Well, this becomes 2x. This becomes minus 5x. 3 times 10 is 30 plus 3x. So here I get negative 3x equals 30 plus 3x. I'm going to move this 3x over here by subtracting. Oops, not 36, but 3x. So what's my problem going to look like now? Well, it's going to look like negative 6x equals 30. And when I divide by negative 6, I get x equals negative 5. All right. So I can get rid of the fractions simply by multiplying every term by the least common denominator and canceling things out. That makes the problem much easier for me to arrive at a solution. Okay, so let's see about applying that in this situation. 5x minus 4 over 5x plus 4 equals 2/3. Now, before we go any further, no, you cannot cancel these 5x's out. No, you cannot cancel these 4's out. Do you see how those things are attached on top? There's actually 2 terms up there and 2 terms down here attached with this and attached with that. Because of the presence of those things, the minus sign and the plus sign, you can't just randomly cancel crap out. It doesn't work. So let's take a look. All right. So if I had 5x times negative 4 over 5x times positive 4. No pluses or minuses in between. Yeah, of course I could cancel stuff out. But here, this has to be treated as one object for the purpose of canceling. Is this object the same as this object? No, then I can't cancel. Or if I could GCF factor something out of this and GCF factor something out of this, and then cancel these things, sure I could do that. But right now, no. All right, so we've got fractions. And what did we just say we could do if we have fractions? Multiply everywhere by the LCD. What's the LCD here? Well, it's this object times this object. So I'm going to be multiplying by 3 times 5x plus 4 and 3 times 5x plus 4. So these will cancel. I'll distribute and get 15x minus 12. And over here, I'll cancel. I'm going to distribute and get 10x plus 8. Okay, so if I subtract 10x from both sides and add 12 to both sides, I end up with 5x equals 20, or x equals 4. X equals 4. Great, no problem. So, can do. Let's try another. How about this one? X over x plus 4 plus 4 over x plus 4 plus 2 equals 0. Okay, so I see a common denominator, but no fraction denominators here. But that's okay. I'm going to get rid of the common denominator by multiplying everywhere by x plus 4, the common denominator. These cancel. These cancel. Plus 2x plus 4 equals 0. Okay, so let's distribute here. X plus 4 plus 2x plus 8. 3x plus 12 equals 0. 3x equals negative 12. And x equals negative 4. That feels pretty good, doesn't it? But no. It turns out that's not the answer. Well, why isn't it the answer? Well, let me show you another way why this is not the answer. I mean, there's nothing wrong with the work we did. The work is all perfect and correct. But I'm going to solve this problem now a different way. X over x plus 4 plus 4 over x plus 4 plus 2 equals 0. And then I see these have a common denominator, so I'm going to write these as one fraction. X plus 4 over x plus 4 plus 2 equals 0. A number divided by itself? Well, that's 1. 1 plus 2 is 3. Does 3 equal 0? No, that's no solution. So I know this problem is supposed to be no solution. So let's have a little conversation about ought check versus must check. You'll notice on the assignment calendar today it says must check number 1. Well, this is must check number 1. When you have x stuff in a denominator, that's must check number 1. Okay? Must check number 1 is if you've got x stuff in a denominator in your equation, this becomes a must check. And what are you must checking for? Well, let's see what happens when we plug in negative 4 for all the x's in our original equation, not a simplified version, into the original. So I'm going to have negative 4 over negative 4 plus 4 plus 4 over negative 4 plus 4 plus 2 equals 0. What's negative 4 plus 4? 0. And what did we talk about in previous videos? Negative 4 divided by 0 is undefined. It's undefined. If I think about this graphically, there's a vertical asymptote at x equals negative 4. Of course that can't be a solution. The function doesn't exist at negative 4. So, must check. And explicitly, when I see x stuff in the denominator, I can't have a 0. So if I get an answer that turns one of my denominators into 0, nope, that's garbage, throw it away. This answer, all the algebra was beautiful and perfect, but when I plug this into this denominator and plug this into this denominator, either one gives me a 0, and because I get a 0 in the denominator, that can't be a solution because a number divided by 0 is undefined. Okay? So we've got our first must check. We must check when we have algebra in the denominator. And we have x stuff in the denominator. How about this one? . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So now I know it's a must check because I have x stuff in the denominator. And in fact, I could say now, if x equals 1 or x equals negative 1/3, when I'm done with my solving, I can throw those solutions away because a 1 turns this into a 0, and a negative 1/3 will turn these into zeros. So that's really what I'm doing when I'm must checking, making sure one of my answers, or both of my answers, as many answers as I have, are not these two numbers, any of these numbers, okay? So what are we supposed to do to solve when we have fractions? We are supposed to multiply everywhere by the least common denominator. And you might say, well, Mr. Cooper, I don't need to write all this out. I can do that in my head. Well, maybe you can do that in your head. Good for you. But what I'm going to say is, having done these problems for 30 years, I make fewer mistakes when I write them out, and I've seen students make fewer mistakes when they take the time to write it out. So it might be worth writing it out. Okay, so I've got a bunch of distributing to do now. 12x plus 4 plus 6x minus 6 equals 15x minus 15. Combine like terms over here. 18x minus 2 plus 15x minus 15. I'm going to subtract 15x. I'm going to add 2. That will give me 3x equals negative 13, or x equals negative 13 thirds. Well, the numbers I can't have are these numbers. Is this one of those numbers? No. So I'm good to go. That's my solution. Okay? All right. Then what about this one? X equals x minus 1 over 3 minus x plus 2 over x minus 3. Please solve that equation. Pause the video, give it a try. Come back when you're done. Okay, welcome back. So I want to multiply everywhere by the least common denominator. And your life is made much easier if you notice that these are almost the same. They only differ by a negative. So if I distribute a negative here, I get minus 3 plus x, which is that one. So if I factor a negative out of these, I'm going to have negative 3 plus x, and then these will be the same. So for me, when I do this problem, I'm multiplying by negative 1 times x minus 3 everywhere. But, let's see what happens if you, instead of using the least common denominator, that's what I would be using, instead of using the least common denominator, you just use a common denominator, 3 minus x times x minus 3. 3 minus x times x minus 3, and over here 3 minus x times x minus 3. So here I've got some canceling, and now I've got x times 3 minus x times x minus 3 equals x minus 1 times x minus 3 plus 2, these cancel, times 3 minus x. Now I'm a little worried over here, because x times x times x is going to be x to the third. But off I go distributing. Now, look, this doesn't get multiplied by all of those. Here's how I know. 2 times 3 times 4. What's that equal to? 24, right? Right. 24, not 48. Huh? Why would that be 48? Yeah, so look, you multiply this times this and get 6 times 4, and then you get 24. But some students would think that that's okay. That is not okay. If I had 2 times 3 plus 4, that would be okay. That's called distributing. But here, no. I'm only going to multiply the 2 times the 3 or times the 4, not both of them, okay? Likewise here, this is the same situation. A thing times a thing times a thing. I don't multiply this to both of those, so I'm not going to multiply this to both of those. All right, so I'm going to have then 3x minus x squared, x minus 3 equals x squared minus 4x plus 3 plus 6 minus 2x. And over here, negative x to the third plus 3x squared minus 9x plus 3, no, I got the 3x squared. Oh, and there's another 3x squared. This one's plus, this one's plus. Okay. All right, so combining like terms, we've got negative x to the third plus 6x squared minus 9x equals x squared minus 6x plus 9. And because this isn't a linear function, this is a higher order polynomial, I'm going to move everything to one side and get this thing equal to 0. So I'm going to subtract x squared, and I'm going to add 6x, and I'm going to subtract 9. Well, where does that take me? That takes me to negative x to the third plus 5x squared minus 3x minus 9 equals 0. All right, factoring by grouping maybe? You know, I've got 4 terms. So if I take out a negative x squared, I'm left with x minus 5. And here I could take out a negative 3, and I'm left with x plus 3. Uh-oh, these aren't the same. And I'm stuck, and I'm sad face. So, guess what? Multiplying by any old denominator didn't work for me. Let's try going back to this problem, but this time, let's use the least common denominator. Okay, that's a positive 3, that's a negative 3. That's a negative x, that's a positive x. That's what tells me these two factors are simply off by a negative. So if I factor a negative 1 out of here, I get negative 3 plus x. That is the same as that, according to the commutative property of addition. So my least common denominator is going to be this thing they have in common, and this other thing. So I'm going to multiply everywhere by negative 1 times x minus 3. Negative 1 times x minus 3, and negative 1 times x minus 3. So on this side, all I can do is have negative x times x minus 3 equals. Now on this side, this goes away and this goes away, and so I'm just left with x minus 1. And over here, these can cancel, leaving me 2 times negative 1 or negative 2. Now, I don't know if you can see it, but this is a whole lot less stuff than when we did that. Okay, so I'm not encouraging you to multiply each fraction by a denominator. I want you to multiply each fraction by the least common denominator. Okay, so because I have a higher order polynomial, something bigger than 1, I'm going to move everything onto one side. No, I think I'm going to move everything over here. I'm going to add x squared, I'm going to subtract 3x. So minus 3x plus an x squared. Okay, so what does the problem look like now? Now I've got 0 equals x squared minus 2x minus 3. And that factors. Luckily, we've done a factor. And now, how do I go from these factors to solutions? Well, think about it this way. When I have a number times another number and the answer is 0, what has to be true about one of these numbers, or both of these numbers? You're multiplying two numbers together and the answer turns out to be 0. What do you know about one of these numbers? One of these numbers has to be 0. Maybe x minus 3 has to be 0. Maybe x plus 1 has to be 0. So let's solve each of these equations. And I get x equals 3, and I get x equals -1. But guess what? Because I have algebra stuff in the denominator, x is in the denominator, this is a must check. Hey, does that work? 3 minus 3 is 0. Can I have 0 in a denominator? No. What about -1? Well, if I plug in a -1 here, 3 minus a -1 is 4. And if I plug in a -1 here, -1 minus 3 is -4. It's no problem having 4 and -4 in the denominator. 0 is the only thing I can't have in the denominator. So I get only one answer, this answer. But more important maybe is, did you notice how when we used any old common denominator, we got to a place where we couldn't actually solve because we had this x to the third that wouldn't factor by grouping? And instead, if we didn't use that, but used the least common denominator, it worked out really easy, simple, and fast. So you really need to use the least common denominator, okay? If you need help talking about, well, how do I find the least common denominator, let me know. And I will see if I can clear that up for you. Oops, that's a -5. Over x squared minus 1 equals 1. Here's a great place for us to talk about least common denominator. Notice this is a difference of squares. And you really do need to notice this is a difference of squares. Which factor is x minus 1, x plus 1? Look, they already have an x minus 1 in common. So this is my common denominator. I'm going to multiply everywhere by x minus 1 times x plus 1. X minus 1 times x plus 1. And here, x minus 1, x plus 1. If you don't do that, if you don't use this least common denominator, but instead do this times this, you're going to end up in that same sucky x to the third it doesn't factor place. So don't go there. Instead, use the least common denominator. So let's do some canceling. And I'm left with 2x times x plus 1. Now our plus sign. Now here, this cancels that, and this cancels that, so all I have left with is x minus 5. Then the equal sign. And there's no canceling here, I just have 1 times x minus 1 times x plus 1, which we know is x squared minus 1. Don't forget to distribute over here. 2x squared plus 2x plus x minus 5 equals x squared minus 1. I'll combine like terms on the left. And because I have something bigger than x to the first, I'm going to move everything to one side. That means I'm going to subtract x squared, and I'm going to add 1. And so that will give me x squared plus 3x minus 4 equals 0. Hey, and we know how to factor a trinomial. X plus 4, x minus 1 equals 0. So when I set each of these factors equal to 0, x plus 4 equals 0 when x equals -4, and x minus 1 equals 0 when x equals +1. These are my two solutions, or are they? Remember, I have x stuff in the denominator, so that makes this a must check. And then, does 1 work? 1 minus 1 is 0. I can't have 0 in the denominator. So I only get one solution here. My only solution is -4. X equals -4. -4 minus 1 is -5. No problem, I have -5 in the denominator. -4 times -4 is 16. 16 minus 1 is 15. Yeah, I can have 15 in the denominator. The only thing I can't have in the denominator is 0, because that makes the expression undefined. 1 turns both of these into zeros. Even if it just turned one of them into a 0, I'd have to discard that as a possible solution. Okay? We're going to eventually have 3 must checks this semester, maybe 4, but I think only 3 situations. And so we have our first one today. All right, now I'd like to come back to the idea of solving in general, and this time focus on solving quadratics. Now we just saw in that last problem x squared minus 3x plus 4. Yes, that was it. So here's a quadratic. How do I solve this quadratic? Well, there's a bunch of different methods. One is to factor the trinomial and set each factor equal to 0. So this factored as x minus 4, x plus 1. Oh, I think that was a plus. That was a minus. I don't know. It's not quite the last problem, is it? So a thing times a thing equals 0 when one of those things is 0. Maybe it's x minus 4 that equals 0, or maybe it's x plus 1 that equals 0. So I get x equals 4, and I get x equals negative 1. Okay? So I've got two solutions here. Does that make sense? Well, let's think about that. This is a parabola, and we know that from our graphing. And this is y equals 0, also known as the x-axis. And so if I think about this question graphically, it's asking me, when does this parabola intersect the x-axis? And I say at negative 1 and 4. Is that true? Oh, no. No, it isn't true. Because look, this is a plus 4, and I don't have a plus 4. Oh, mercy. Can we just start over? Here, pretend I didn't say anything. And let's start with A. The first method of solving quadratics is by taking a root, or taking roots. What does that mean? Well, like in this one. Here's a quadratic. I want to find out what x equals. How do I get rid of x squared? I take the square root of each other to find the roots of this function. What am I supposed to remember when I take the square root of both sides? Don't forget that plus and minus. And the square root of 169 is 13. Okay? Thinking about this graphically, I've got our regular parabola. I have the line y equals 169. And I notice that line y equals 169 intersects in two places where here at positive 13 and here at negative 13. Okay? So the biggest issue with taking roots, I think, for students is remembering to do the plus and minus. Let's practice one or two more of these. How about this one? X plus 10 squared equals 25. Now, some students like to FOIL this out. X squared plus 20x plus 100 equals 25, and then they want to subtract 25. And then they want to factor this or something else. No, look, you've got one term on each side, and both of those things are perfect squares. So take the square root of both sides. So what do we end up with? X plus 10 equals, what do we have over here? No, not just 5. You took the square root of both sides, so you have to remember the plus or minus. Now I'm going to subtract 10. And I'm going to have x equals negative 10 plus or minus 5. That's negative 10 plus 5, or n, because it's both of these, negative 10 minus 5. So I get two solutions here. And again, that makes sense to me. You know, if we think about this problem graphically, this is our parabola shifted left 10. And when is this parabola going to cross the line y equals 25? Well, it's going to happen twice, so there better be two solutions, and both of them should be negative. All right? Use that graphing that we've done to help you think about the reasonableness of your answers. All right, so we're still taking roots. What about taking the roots here? 2x minus 1 squared plus 4 equals 22. All right, so yeah, I can't take the square root of both sides here because I've got these two things joined with this plus. So I could do this, because that's what I'm doing. I'm only taking the square root of the whole side of the equation. And I can't simplify that, actually. So instead, what I'm going to do is I'm going to start by subtracting 4. And now I can take the square root of both sides. And it's at this point when I say, okay, I took the square root of both sides, so I better remember plus and minus. Okay, this can be simplified to plus and minus 2 root 2, but I'm not done solving. I still have this stuff. So I'm going to add 1. That's going to give me 2x equals 1 plus or minus 2 root 2. And when I divide by 2, I end up with this. X equals 1 plus or minus 2 root 2 over 2. Can I do that? No, I can't do that. How eager you are. No, you can't do that. If you could take a 2 out of all of them, you could do that. But since you're only trying to take 2's out of this, that doesn't work. You can't do that. Right? And if you ever want me to show you why you can't do that, by all means let me know. If we had something like this, sure, I could factor a 2 out of the top and then cancel the factor on the top with the factor on the bottom. But these aren't factors, right? They're joined with plus and minus. Okay, so one way we can solve quadratics is by taking roots. Another is by factoring. And we practiced a lot of factoring over the last 2 days so that we would be comfortable when we got to problems like this. So, any factoring we can do here? What's the first type of factoring we're supposed to do? Ah, right, GCF factoring, good. What would the GCF be here? 3x, nice. So we're going to be left with 2x plus 0. No, no, no. 3x divided by 3x is 1. Now I've got two things multiplied together. When is the answer to that multiplication problem 0 when one of those things equals 0? Maybe it's 3x that equals 0. Maybe it's 2x plus 1 that equals 0. So when we're solving quadratics, when we're solving polynomials greater than degree 1, we always want to get everything on one side so that we can have this equal to 0. This idea of setting factors equal to 0 works, but if this were a 5, I can't set factors equal to 5, because then I don't know anything about one of these numbers. Okay? I can only set factors equal to 0. So in our case, I divide by 3, I get x equals 0, and here I subtract 1, and divide by 2, and I get 2 solutions. Okay, and again, think about this as a parabola. Okay? It's a parabola with x-intercepts of 0 and -1. And that's what this is telling me. When does this parabola intersect the x-axis? Why here and here, in these two places. Okay, so let's practice factoring some more. How about this one? X plus x squared plus 10x plus 25 equals 0. Well, what is that factor? What do you see to put here and here? That's right, those have to be x's because x times x makes x squared. What am I going to put here and here? Does 25 and 1 work? That's not going to make 10. How about 5 and 5? In fact, we could rewrite this as x plus 5 squared equals 0, huh? Okay, but we're here, and then we set the factor equal to 0. I don't have to do it twice because it's the same factor. And this time when I solve the quadratic, I get only one solution. Is that okay? Well, think about this graph. This is the parabola y equals x squared shifted left 5. 1, 2, 3, 4. And we ask the question, when is this parabola equal to 0? Why, only here at negative 5. It touches and then bounces off the x-axis. Oh, just like multiplicities. Oh, that's a multiplicity of 2. That's a bounce at negative 5. And because we're bouncing at negative 5 there, we're not passing through and then coming up somewhere else again. We only get the one solution here. Mr. Google, what about taking the square root of both sides? Sure, I take the square root of both sides. Plus and 5 and plus and minus 0. So plus and minus 0, sorry, that's still just 0. And so I subtract 5 and get x equals negative 5. Okay, so more factoring. How about this one? 5x plus 3 equals 2x squared. Now, when I think about this graphically, I think about a linear equation with a positive slope and a positive y-intercept. And I think about a parabola with a vertical stretch to it. 3, negative 3/5, and then our parabola. So I'm expecting 2 points of intersection here. Well, let's see if we can find them. Now, should I take the square root of both sides? No. Remember, we're talking about solving by factoring right now. And what do we need to do? Because we see this squared, we need to move everything onto one side of the equation. So I'm going to subtract 3 from both sides. I'm going to subtract 5x from both sides. And I'm going to get 0 equals 2x squared minus 5x minus 3. So please factor that trinomial. Set each factor equal to 0. Find what the solutions are to this equation, or where this parabola crosses the x-axis. Okay, welcome back. So this factors as 2x and x and minus 3 and plus 1. So when I set these factors equal to 0, I get x equals negative 1/2 and x equals positive 3. Okay? Okay. So, last one with factoring, and then we'll move on to our next type. How about this one? 2x squared minus 19x equals 33. Okay, don't do that. That is wrong, 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 wrong. Remember, before you do any factoring, if this is higher than first degree, you've got to move everything onto one side of the equation. So what we really need to factor is this. Okay? So 2x, x minus 11 plus 3. Negative 22 plus 3 is negative 19. And so I end up with 2x plus 3 equals 0. So x equals negative 3/2. X minus 11 equals 0. So x equals 11. Often with quadratics, I get two solutions. Sometimes I get one solution. Sometimes I get no solution. So think about this again graphically. We've got this parabola that points up, and crossing the line, y equals 33. I see 2 points of intersection. Okay? We saw 1 point of intersection with this problem, and that's because we were bouncing off of negative 5. And then if we had something like this, x squared plus 1 equals 0, I subtract 1 from both sides, I get x squared equals negative 1. Can I take the square root of a negative number? Nope. So there's no real solution here. Think about this graphically now. This is our parabola shifted up 1. This is the line y equals 0. When does this parabola intersect this line? Does this parabola intersect this line? Nope. So there are no real solutions. Okay, so with quadratics, I could have no solution, one solution, or two solutions. Okay. We've talked so far about solving quadratics by using factoring and by taking roots. Well, what about the quadratic formula? You want to sing along with me, or am I going to sing by myself? X equals negative b plus and minus square root b squared minus 4ac all over 2a. So when I can't factor a quadratic, I reach for the quadratic formula. Okay, so 2x squared minus x plus 1. Yes, I know I can. Oh, can I factor that? No, I think I can factor that. 2x, x, 1, 1. Both of these minus. That's minus 3x. Both of these plus. That's plus 3x. Uh-oh, this doesn't factor. So when I have something, a quadratic that doesn't factor, I use our quadratic formula. Here's a, here's b, and here's c. A is the coefficient in front of the x squared, b is the coefficient in front of the x to the first, and c is the constant. So in our problem, we're going to have x equals negative b. Well, b is negative 1, so if I want negative 1, that's 1. Plus and minus square root, negative 1 squared is 1, minus 4 times a is 2, c is 1. All over 2 times 2. So notice what's going to happen here. I'm going to get 1 plus and minus square root negative 7 over 4. Can I take the square root of a negative number? Nope. No real solutions. In our polynomials unit, we'll start talking about imaginary numbers. And so if you're comfortable with imaginary numbers now, you can say I root 7 all over 4. But again, that's not a real solution. And in our Algebra Basics unit, we're only looking for real solutions. Please make sure you know the quadratic formula. I'll sing it again. I'm not scared. X equals negative b plus and minus square root of b squared minus 4ac all over 2a. All right. So how about you practice with this one? X squared plus 2x minus 5 equals 0. You know, I can't take the root because I don't just have one thing on each side, and this doesn't factor for me, so that means I'm using quadratic formula. Pause the video, use the quadratic formula, come back when you're done, and we'll check answers. Okay, so a equals 1, b equals 2, c equals negative 5. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. We've got negative 2 plus and minus square root of 24 over 2. No, you cannot cancel those. Stop it. Instead, you can simplify this. Negative 2 plus and minus 2 root 6 over 2. Notice you can take a 2 out of both of these. Sure. Negative 1 plus and minus root 6 all over 2. Now you can cancel. You can take a 2 out of all of them. Okay? So my final answer is negative 1 plus and minus square root of 6. Two solutions to this up-pointing parabola with a negative 1 intercept. You know, if I think about this graphically, I believe this is my graph. And look, two solutions. Two places where the parabola equals 0. Two places where the parabola crosses the x-axis. These are the two places. Negative 1 minus root 6 and negative 1 plus root 6. Oh, so quadratic formula, but clearly I don't want to do quadratic formula if I'm comfortable with factoring. I can factor, because factoring is factoring. I would also recommend that if you're one of those people for whom factoring does not go fast, and you want to use quadratic formula because it'll always work, yeah, that's true, but you're never going to get better at factoring if you hide from it all the time. I would actually force myself to practice the factoring. Okay, we have one last method of solving quadratics, and it's the one that I like doing least. It's the most time consuming in general, completing the square. Okay, so what I'm going to do with completing the square is turn something into a perfect square so that I can take the square root of both sides. And we saw a little bit about perfect square trinomials in our factoring unit. This is a perfect square trinomial, and here's how I know it just by looking at it. This is a perfect square. This is a perfect square. And the middle term is the square root of this times the square root of this times 2. So here's a perfect square trinomial. We could write it as x plus 5 squared. And so then, if I had, 4 on the other side, I'd just take the square root of both sides and solve that. So yes, I can do completing the square, and no, I don't want to do completing the square. In fact, I'll say this. When we're solving these equations, there's almost never a need to do completing the square. And that is until we start talking about conics. And we'll start doing that in our unit which has circles in it. When we have to write the equation of the circle, we're going to need completing the square. You are not required. I will not put on any test for CFA for us completing the square solving equation problems. But we will need completing the square. And because we're going to need completing the square, I'm going to show you completing the square now because it's a method for solving quadratics. All right, so here's the first one. X squared minus 2x equals 0. Okay, so the first thing I want to do is I want to isolate the x stuff. Okay, isolate the x stuff. This is already isolated. Well, that's great. Then, remember how we said ax squared plus bx plus c? This was the a was the number here, and the b was the number here. Okay, so what I want to do when I've isolated my x stuff is I want to add to both sides of the equation b over 2 squared. Well, my b value in this problem is negative 2. So I'm going to add negative 2 over 2 squared to both sides. Well, negative 2 divided by 2 is negative 1, and negative 1 squared is 1. So now I've got x squared minus 2x plus, and this is 1, equals 1. Now I need to factor this trinomial. And this trinomial is going to factor as x minus 1 equals 1. Look, they're both the same. Because I used completing the square, I turned this into a perfect square trinomial so that I could do x minus 1 squared equals 1, and then take the square root of both sides. X minus 1 equals plus and minus 1, x equals 1 plus and minus 1, so 1 plus 1 is 2, and 1 minus 1 is 0. So I get these two solutions. Solutions at 2 and 0 by using the completing the square method. Now, I will say that we could save a little time if, remember how we had negative 2 over 2 here? And negative 2 divided by 2 is negative 1. Well, take a look at our factored form. This is our factored form. Notice this unsquared thing went to both of those. So I don't really have to do the factoring. In fact, if I don't square this, that number just goes in both of those places. Here, let's do another one. I'll show you what I mean. Okay, how about x squared plus 4x minus 32? Okay. Yes, I know we can factor this. We don't need to do completing the square, but I'm going to do completing the square. First, I'm going to isolate the x stuff. So I'm going to have x squared plus 4x equals 32. And then, remember, I want to add b over 2 squared to both sides. Well, here the b value is 4. 4 divided by 2 is 2, which is 4. So on this side, I'm writing it as 4, but over here, I'm writing it as 2 squared. And the reason I'm doing that is because I know that this will factor as this. This number goes in both of those places. Over here, though, I don't want 2 squared, I want 4 because I have to add these together. And so now I've got x plus 2 squared equals 36, and I can take the root of both sides. Don't forget the plus and minus, or you're throwing one of the solutions away. Now, you can't stop here. Negative 2 plus and minus 6. That's not okay. You really do need to say x equals negative 2 plus 6 or 4, and x equals negative 2 minus 6 or negative 8. Those are my two solutions, okay? But again, I could have done this with factoring a lot faster. Why use completing the square? Well, I think it's crazy to use completing the square. But I need you to know how to do completing the square for when we get to our conversations about circles, and you have to use completing the square. Okay, remember how I said that the first step was to isolate the x stuff, and then we added b over 2 squared to both sides? That's still what I want, except now I want a step called 1.5. I want a step in between. And that's where I turn a into 1 by dividing. Okay? Because when I look at this next problem, 2x squared plus 8x minus 6 equals 8. I can isolate the x stuff by adding 6 to both sides. But see that a value? That a value isn't 1. I need to make that a value 1. And what I have to do is divide by that a value, by dividing by a. Okay, so I'm going to divide by 2, divide by 2, divide by 2. So I get x squared plus 4x equals 3. And now I'm ready to do this step where we add b over 2 squared to both sides. 4 divided by 2 is 2, so I'm adding 2 squared to both sides, or 4. Over here, I have x plus 2 squared equals 7. And then it's time for me to not only change markers, but take the square root of both sides. So I get x equals negative 2 plus or minus square root of 7. No, I don't need you to write negative 2 plus root 7 and negative 2 minus root 7. This is fine for that. But if this were a 7 and not a root 7, then yeah, I expect you to take this to negative 9 and positive 5. Okay? But our answer has a square root of 7 in it, and so that's sufficient. All right, so let's do one last completing the square problem, and then review and call it a video. So 3x squared minus 6x minus 4 equals 0. All right, the first thing I want to do is what? I want to isolate the x step. 3x squared minus 6x equals 4. Can this be equal to 3? No, a has to be equal to 1, so I have to divide everywhere by 3. So now I've got x squared minus 2x equals 4 thirds. Alright, we've isolated the x stuff. We got a equal to 1, and now we have to add b over 2 squared to both sides. My b value is negative 2. Negative 2 divided by 2 is negative 1. So I'm adding 1 to both sides. This is going to factor as x minus 1 times x minus 1. And over here, 3 thirds plus 4 thirds is 7 thirds. This can turn into x minus 1 squared. And then we can take the square root of both sides. Space. So now we're going to have x minus 1. Don't forget the plus and minus. Root 7 thirds. Now, I generally prefer to write this as plus and minus root 7 over root 3, and maybe even to rationalize, so that I have x minus 1 equals plus and minus root 21 over 3. Don't forget you still need to add 1, so I have 1 plus and minus root 21. Not all of it, just over here. I mean, if you wanted to make a common denominator and say x equals 3 plus and minus root 21, everything over 3, that's legit. But no, this 3 right now is only this. I would not mark wrong on a test student who wrote x equals 1 plus and minus root 7 thirds. I would just frown at it. Say, ew. Alright, so there we are, completing the square as a method of solving quadratics. So we talked about a bunch of things today. They were all involving solving. The first thing we said was linear terms. When you have x to the first. When you have these linear terms only, that's when you want to get x's on one side and numbers on the other. Okay, we saw when we were solving some quadratics, though, or higher degree polynomials, that we should move everything to one side so this can be equal to 0. Okay? What else did we talk about today? Well, we talked about 4 ways of solving quadratics. First, by taking the square root of both sides. Remember, this only works if you've got one squared thing equals something else, right? It can't be a whole bunch of things joined with plus and minus. It's only, I got a thing, I got a thing, I take the square root of both sides of the equation. Okay. We also reviewed solving by factoring and setting factors equal to 0. Then we used quadratic formula, x equals negative b plus minus square root of x equals negative b plus minus square root b squared minus 4ac all over 2a. We really will need that formula. And then d, the one I'm not expecting you to use in this unit, but we will need to use later, completing the square. Okay. Did we do anything else in this video? Why, yes. we had our first must check. Must check number 1. X's in the denominator. We're checking to make sure, your solutions don't turn the denominator into 0. Okay? What else? Well, that we learned about must check number 1 when we were solving equations with fractions, and we said that when solving these rational equations, we want to multiply by the LCD, not just a common denominator, but the least common denominator. All right, well, I think we're ready to try the homework. I certainly would recommend it. And our homework tonight is bookwork. It's again in the appendix, so look for it there. And I'll see you in the next video. Please don't forget to ask questions.